Thanks, Maggie. Well, actually, I think this is a great segue. I just walked in. It sounds like you guys were talking a lot about passwords. And I spent a lot of my time talking about passwords, even though I don't deal with passwords. And I'll explain a little bit why in a little bit. So as Maggie said, I'm Mark Cooper. I'm the president and founder of PKI Solutions. I actually am based here in Portland. I started the company about 5 years ago after leaving Microsoft. At Microsoft, I spent my time working just in the PKI space. So it's been about 20 years now that I've been focused just in the public key infrastructure. PKI is something that is kind of very near and dear to me. It was one of those technologies when somebody sat me down and said, we need you to kind of learn this. Everyone's afraid of it, and no one really understands it. Does anyone have that feeling about things like PKI or other types of security? Yeah. You know what I found? There's something to be said for understanding and really being passionate about a technology niche. It makes it much easier to develop a very deep skill set. PKI has really been that one thing for me. As much as I like to go around saying I'm the PKI guy when I was at Microsoft, I can't really say that Bill Gates came down and anointed me the PKI guy. I kind of hacked a system accidentally, and it wound up replicating throughout Microsoft, and my job title changed. Luckily, my boss was okay with it, but I didn't get paid for a little while, so I had to get that fixed. So if you ever saw Office Space and the glitch, I inflicted the glitch on myself for a little while. So PKI Solutions, we primarily focus on identity and encryption, doing training, consulting, and working with customers to design PKI, but it's often driven by a very central problem that you're probably facing in your organizations today. So today we're really going to be talking about this concept of secrets. Secrets kind of vary by organization and what you're trying to protect, but they all kind of go back to the same thing. From a business to a department or an agency, whatever you are working in, the odds are you have some piece of information, whether it's data or identities, or even intellectual property, that is a secret to you, that you're not trying to openly share with the world. Most organizations have something that they need to keep secret. Sometimes it's passwords, sometimes it's the data you're processing, sometimes it's just the very nature of what you do. So if you've ever gone to organizations where there's lots of physical security and there's lots of well-defined processes, they're trying to control access to things. From a data perspective, that becomes much harder. So what we wanted to talk about today was trying to define what are some of these secrets that you're most likely already running into in your organization, what are some of those challenges, as well as what are some of the things that you could be doing to address those secrets. So some of the things I wanted to talk about today, let's take a look at what we're currently seeing in the landscape. And it's not meant to be a real in-depth overview of the IT landscape, but just to kind of give you a foundation of what we want to talk about. But talk about what those typical secrets are, and I want to share some solutions and options with you that you could actually explore today. So I didn't want this just to be a nice abstract talk on secrets and concepts that you should do. I want to give you some options that you can actually walk away with and actually consider if you're not already using some of these in your organization. So in the landscape that we have today, most organizations are either currently being affected because secrets are being leaked out of the organization, or they're actively trying to do something to prevent that. Has anyone actually suffered any type of a loss of data or identities or passwords that you know of? A few. How many people think maybe you have, but you just don't know? Yeah. That's kind of what most organizations kind of function under. Either you have or you suspect maybe you have.
No,
most organizations.
No, it's more like either you know you have or you're kidding yourself.
There you go. There is an eventuality. The concepts of what information people are after changes from year to year. I've been in the IT space for 30 years. Early in my career, we used to say the only people that were subject to potentially hacking were federal agencies, people with patents and IP and hidden secrets and formulas like Coke. And you could say, well, we're not Coca-Cola. We don't have some secret recipe. We don't need to worry about IT security. No one's after my information. That's kind of completely changed. now is interesting for me years ago, having heard about healthcare information, one of the most valuable pieces of information that hackers are after. So what we may be facing today is going to be very different tomorrow. The management of these secrets is also changing. The concepts that we're dealing with now, different than 5 or 10 years ago, moving things into the cloud and hosted services and managed services. Years ago, it used to be we kept all that stuff in-house. We had physical barriers. We had well-defined protections. We weren't taking our data and sticking it out on the internet. It used to be even where I worked at organizations in corporate IT, where we would say if anything was coming from the internet and touching our environment, we didn't want them to access our critical information. Maybe you can connect to get email. Now organizations are wholesale shifting a lot of information into the cloud and not giving a whole lot of thought about what are we putting up there and how are we protecting it. So the landscape is changing. We're no longer being tasked with how do we build walls and keep people out. It's how do we put things out in the world and hope and prevent people from reading it. And it takes one misconfiguration now. It used to be if it was sitting on your server in your data center, if someone couldn't physically get into your building, your information was protected. It was only the employee that may steal something. Now it's sitting in Azure, it's sitting in AWS, and hopefully someone doesn't misconfigure something. Very different landscape. So from a concept of secrets, secrets are often associated either with information or data. And every organization is a little different as far as how they're managing secrets, but the things that we typically see are things like passwords. And it's one of those things that, just like the session before, lots of talks about passwords. How do we make sure our users don't have weak passwords? In many ways, that's managing a secret. How do we make sure that their secret isn't so easy to guess that someone else is out there impersonating them? Also, how do we make sure it's not so complex that they can't possibly remember their own password? We also have issues around encryption. Most of you probably have some type of encryption you're doing in your organization, whether it's encryption of files, maybe your entire disk of a BitLocker, it could be data encryption, but you're doing some type of encryption, and it may be embedded inside an application, but most of us know that if there's a checkbox to encrypt, it must be more secure, but we're not often giving a lot of thought to how is that encryption being protected, where are those keys, but those underlying secrets potentially become a big issue. Anyone remember the Sony hack from, what was it, 10 years ago now? So one of the most interesting stories for me out of that wasn't so much of the information about the celebrities and all the dish and the salary. There was a code signing certificate that was in that trove. Did anyone ever hear the story about this code signing cert? So there's some irony. If you go back 20 years, Sony had some really bad publicity around 2000. They were putting a rootkit into all of their music CDs. Remember this? So they were used to signing code. They were putting these things on their CDs. Well, when the Sony hack went out, it wasn't the same certificate, but it was along the same lines. Their code signing certificate with the private key and the password were in the information that was disclosed. Now, it's not necessarily that embarrassing, but the interesting thing is a researcher took that code signing cert and signed a piece of malware and then sent it to a buddy saying, hey, look what Sony's up to. Well, the story got away from him. The buddy didn't realize it was a joke. He simply saw, hey, here's a piece of malware signed by Sony. What was Sony up to? That's really bad from a reputation standpoint. Now, there wasn't a lot of mainstream press covering that, but that's just an example of secrets getting out and unintentionally affecting the reputation of an organization. Other places that we're looking at, things like crypto wallets, people doing Bitcoins and other types of digital currencies. All of that information goes back to maintaining some secret that is your digital wallet. We see the same things with API keys. A lot of the cloud providers now aren't necessarily using passwords, but they have some type of a token or an API that allows one application to talk to another application. It might as well just be called a password. If you go into a screen, it says, okay, paste your private API key here or your private token. change the label to password, because that's all they're really doing. It's just a password. Well, all of those secrets need to be managed somehow. Now, things like passwords, we've got nice established practices for, but not a lot of people are thinking about how are we managing these encryption keys? How are we managing these tokens? What are we doing to get ahead of this problem? So there's a couple of things that I often work with customers to try to figure out is, in order to get your handle around the secrets, part of the problem is trying to figure out what secrets do you have. And it's not that they've necessarily done a great job obscuring this information. It's a lot of times they just don't know what it is. You sit down and say, what types of encryption keys do you have? What types of API keys do you have? How are your applications working? And a lot of times they go, I don't know. So a lot of this is actually just effort, trying to figure out what types of secrets are we using and how are we going to go about managing them. So a couple of things that we need to do. One, try to figure out what secrets, what types of keys you have. I have gone into large organizations where I expected the IT shop to have a pretty good handle on, here's our systems. No, they don't. And the discussion often goes, here's what we should do, but you're probably not going to do. You should have a list of what all these critical systems are, and let's go figure out what types of encryption they're doing, what types of keys they're using, what types of tokens they have. And the IT, the security, the director, the VP goes, I don't know. Don't know what it is. So then I go, okay, let's take this as a more practical approach. What makes your business function? If you're a bank, the ability for tellers to take money in and do wire transfers and ATMs, you should be able to at least establish what's your critical thing. What keeps the lights on, makes your widgets. No, we don't know that either. And this is happening everywhere I go. So if we want to talk about responsible security and managing data correctly, if you don't even have an accurate idea of where you're doing encryption and what that data is, there's no way you can get ahead of this. And then you start scattering this stuff up into cloud, managed services, offsite services. How are you ever going to figure these things out? You have to start somewhere. If you can't identify every system, figure out what you do know. Touch what you can. You know, there's an old saying, how do you eat an elephant? One bite at a time. It's going to take a while to get through all of it. And if you don't know what all those systems are, at least figure out what you do. If you're managing an email system, if you're managing a GitHub, whatever repositories you have, at least put that on a spreadsheet and say, let's figure these things out. And when you get that done, you'll find out what that next thing is. But you have to start somewhere. The other thing is you need some way of controlling access to those systems and to those private secrets. If you don't have a way of protecting and managing those secrets, there's nothing that you can do from an inventory standpoint or from a documentation standpoint or security if you can't control access. If you bring all your secrets into one place and you can't control them, what have you just created? A honeypot. You have created a very attractive place on your network for someone to attack. So don't bring all of these things together without some plan of how you're going to protect them and control access. The other thing is try to figure out what types of permissions you have out there. Who is able to create these keys? Who's able to make these connections? Who's changing secrets? Who's implementing these secrets? These could be functioning at user levels. They could be machines, applications and processes or services. There may be a whole set of applications that you don't have visibility of that are either affecting or changing these secrets or unintentionally divulging information about them. So you really need to know what's at play here. And again, like I said, if you can't get a grasp of what all of those systems are and what all of those applications and processes are, start with what you can. Identify that core list and then grow from there. The other thing that we need to do, once we start tracking down what types of keys and APIs we are using, is try to figure out how they're using and what that normal pattern is. One of the difficult things that we have is detecting abnormal use. If I know I have a particular key and that token should only be used between these two applications, and suddenly it starts being used somewhere else or coming off of the internet or being sent to a cloud service, those things are something that I want to detect. The good thing is a lot of these secrets tend to be static. When we start looking at things like encryption keys, these tend to be things that are long-lived. One of the benefits of not using passwords is these secrets, if well managed, can be valid for longer periods of time. So there was a question earlier about passwords of 30 days, 90 days, 60 days. Why do we change them so frequently? Because they're so easily guessed, they're so easily worked around. These secrets, when we start talking about encryption keys, have theoretical lifetimes of hundreds of thousands, if not millions of years. Well, if I have information that is statically protected by these keys, I should be able to define some type of pattern about where is the information being decrypted and where is it going. One of the fundamental things I try to work with customers on is, yes, protect your network. We don't want attackers coming into our network, but I'd rather you define your network as one that if somebody was on your network, there's nothing they can really get to. If you encrypt your information, if you protect your host and protect your secrets, I, in theory, could have someone wandering around my network and not have to worry about my data being divulged. Now, that takes a lot of discipline and a lot of effort, but if you build to that level, you're not doing this Twinkie approach. Have you heard of the Twinkie security model? If you put all your protection, your firewalls and all your antivirus and all your SSL scanning on the perimeter of your network, you breach that little soft yellowy filling and you get to the very soft, creamy center of that Twinkie. If you puncture that little exterior hole, there's nothing to protect you once they get inside. If you start managing your data where it's encrypted at all times, you're practicing defense in depth. You're making sure that your secrets and your data are protected. The other thing that we need to do is, if we're going to start managing our secrets, is having a plan of attack of what are we going to do if one of our secrets or the data that they protect has become compromised. Inevitably, there's going to be attacks, there's going to be loss of information regardless of what you do. One of the challenges that we have is that we can protect against the scenarios that we can define. It's the undefined scenarios that we're not going to be prepared for. How many people in this room are kind of your network or systems administrator or cyber engineer? Like, you have some role in your organization when it comes to security. Okay, everyone that just raised your hand, you're my worst nightmare, because you have your hands in all of these systems. You know the passwords to systems, you've got the scanning systems, you are the ones that your organization trusts. But how do we make sure that organizations aren't trusting the wrong person? And a lot of organizations will say, well, we trust our administrators. We've never had a problem. Okay, what about the next hire? What about that next person you bring in? And they're going to have all the same access you do. So some of the things that we can do are actually implementing things like two-person integrity, where certain types of secrets can only be accessed if two people are present. So there are some times where we have to define how are we going to protect ourselves against ourselves. So trying to figure out where our secrets are kept. As I said, there's the application approach. There's also just looking at all the different platforms that we are using in our organizations to find where these keys are at. Obviously, there's the on-premises, our servers, our applications, our PCs. Don't forget those things that are outside of that central data center. And it's not always just our servers sitting in a data center or sitting in a rack that we can physically go up and touch and say, I have some type of data here, some type of encryption. Our user systems, there's often things throughout the organization that has some type of data that needs to be protected. We all kind of have heard stories about laptops that get stolen or some spreadsheet that somebody had downloaded information. So it's not just our main servers that have this information. Now we have the complexities of things like cloud and managed services. I've even had customers where they have information that's kind of not quite in either one. It's on premises, but they don't own it and they don't manage it. So all of those types of managed services where maybe there's a third-party vendor that has equipment or server or data sitting on your network that has your secrets or your data, and may not even be something that you're touching on a daily basis. So what are those other things that your vendors or partners or solution providers are putting in your facility? What types of information do they have? We obviously have things like flash drives. How many organizations have some type of policy against flash drives? I'm seeing this more and more. Don't bring a flash drive in. If it try to plug it in, we're not going to recognize it. Either a central flash drive, or you have to take it to a central location, cutting off those types of places. From an organizational standpoint, flash drives are nice and convenient, but usually means information is going somewhere that we can't track. The other thing is encode. Any developers in the room? Okay, please don't put secrets and passwords and tokens and APIs into your code. I can't see them, I can't manage them, and I don't know they're there. The other thing is, despite your best intentions, they never get updated in the next release. I've seen software where people have said, you know what, we're just going to change this every couple of weeks with a new release. It's never going to matter. And then eventually that manufacturer either ceases to update the product, or a new developer comes in and goes, I don't want to break anything, so I'm not going to change all those old keys. I'm going to leave them in there. You cannot obscure your code enough to make any secrets or passwords safe inside of code. If it's statically defined somewhere, someone's going to find it. It also makes it very difficult from a centralized management. If I want to increase or rotate keys or track those encryption tokens, if it's inside of your code and I'm not looking at your code, I may not even know it's there. So one of the challenges that we often come up with is organizations that say, I get it. We want to protect this information. We want to encrypt the information. I understand what you're going for, but I don't know how to do this. This is kind of your typical chart for any type of project. You could plug in any name here. You know, the more secure and the more robust it is, the more time, the more cost. You know, the old adage. You can have it fast and secure, but it's not going to be cheap, and you can take any two, but you can't have all three. So from a project perspective, you can sit here and you can graph this all out. Here's what I really do with customers. I sit down and I say, do you want to be the carrot or do you want to be the stick? You have to make a decision. Are your vendors going to drive your security and your secrets management, or do you define them? And what that comes back to is you can say, what can all of my existing applications do? And whatever they can all do, that's my security. If they all can provide SHA-1 hashes and they have passwords of 8 lengths, 8-character length, that must be the best security I can do, and pat myself on the back and I move on. Or I take the other approach. I say, let's define what I want my security to look like. I want all of my applications to be using X. If you're going to stick with passwords, you come up with your password complexity. If you're going to use PGP, you define what that complexity is. If you're going to use encryption and private keys, you define what that is. And you may not be able to tell your vendor, I want you to do this today, but you set your goal. You say, okay, it's 2018. By 2021, I want all of my applications to meet this standard. You must be able to support symmetric keys. You must be able to support whatever that is. And you define your vendors and you say, if you want to continue to sell your product to us, you have 3 years to meet this. If you can't meet this goal, you will be replaced. So you may not even be able to affect the security today, but you can at least define what that eventuality is. And you may even have several tiers there. You may have that 1-year goal, 3-year goal, 5-year goal. Then make sure that's part of your organizational approach. If you're an organization that does RFPs or some type of application verification before you bring the product in, make sure that standard is in there. So if you expect to be using SHA-256 hashing for something, make sure that's part of your vendor evaluation, part of your application verification process. And if it doesn't, say you failed that part. Either fix it, give us a commitment to do it, or we're going to find another product. So organizations need to proactively define what they want their security to be. And you can all do that. It's a matter of, is that 1 year, is it 5 years, or 10 years? Obviously, the less purchasing power you have, the smaller you are, smaller your budget, you may have to have a longer tail to get to that standard. If you're a large organization, you can throw your money around and go to organizations like Amazon or Microsoft or SAP and say, if you want to continue in our organization, we have a 2-year standard. You must be able to take all of your encryption keys and have them centrally managed. So you can define these things. So from a security perspective, the other thing that you can define is how secure do you want this to be? Is this going to be just a simple centralized? You're going to take all those secrets, all those passwords, and centralize them in one place and not necessarily improve upon the security, but they're going to be in an auditable location? Or do you want to ramp this up a little bit? So from the limited access standpoint, we're really talking about how do we identify these secrets and then somehow control them? Anyone using things like LastPass or other types of password vaulting scenarios? So this is an example of kind of limited access. You can put all those secrets in there, not great for things like encryption keys and API keys, but for passwords. And you can somewhat control that access. So in that case, you're taking a lot of those secrets out of those Post-it notes and emails and text files that are around and putting it in somewhat of a controlled fashion. Doesn't work for a lot of other types of technologies. The other option is we start looking at how do we encrypt some of these secrets. How can we take our API keys, how can we take our symmetric keys, our passwords, or tokens, whatever we have, and encrypt them beyond just a password manager. This is going to take more effort. There are technologies out there where we can manage this information, but if you think about LastPass or some other type of password vaulting scenario, and you expand it to include things other than passwords, we're kind of going along those lines. The other thing that we do is we can move beyond that and start looking at how we actually manage these secrets. How do we actually control the changing of the secrets, changing and rolling of keys? How do we actually control access to them? So if you've looked at things like CyberArk, anyone using CyberArk? Okay, you can see kind of a much smaller subset. If you don't know what tools like CyberArk are, these are ones where people don't even have access to the secrets. LastPass, you put the password in there if you want it, you can look at it, you can copy it out, you can autofill some form, you see the password, you can divulge it. Things like CyberArk, you don't even see the password. You connect into a server, well, you actually go to CyberArk, CyberArk signs into the server for you. You never see it. So there are ways of increasing the security of that information. So a couple of things that we need to watch for when we talk about why do we want to be concerned about secrets management? Or if you're going to go back to your organization, how do you convince someone that you should spend the time tracking these applications down, managing the passwords? Why is it worth that investment? The problems that we run into is when we start looking at accounts or our networks getting compromised, ultimately means there's something on our network or something about our organization that can get divulged. If you're an organization, perhaps like a university, where you just let anyone connect in, odds are there's still parts of your network that you don't want people getting to. You're always going to have something that you don't want compromised. Is anyone in an organization where you don't care who looks at what? I mean, like anyone. Yeah, not usually the case. Most of the time when we're put together as even a cooperative or an education institution, there's still something that we need to keep away from other people. So when we have poor management of those secrets, passwords, encryption keys, we face divulging that information. We have things like data breaches and outages. Now, this moves beyond just information's been divulged. It means our organization perhaps isn't even able to function. We're down for a period of time. We can't function as a business. We can't have bank tellers working. Students can't get onto online courses. It affects us materially. It also has a direct cost. You have to go fix it. And if you're one of those people that said you're part of the security team, guess what you get to do on the weekend? You get to go in and fix this. So there's a direct cost to not doing this. And this is one where organizations will oftentimes take the short-sighted approach. They'll say, well, it's going to cost me X dollars to go out and buy something. It's going to cost me X dollars for you to go out and inventory all these systems, and then we're going to go out and spend $5,000, $20,000, $50,000, $100,000 on something to manage this. And they go, yeah, I'm not worried about that. But what's the cost when there is an outage? Like, what happens on a per-minute basis? And some organizations, this is a real easy calculation. You go to Amazon, and they could probably tell you each second that their site doesn't function, they lose X dollars. So that becomes a real easy metric. Hey, if I can buy a solution that we can estimate saves us X amount of time or prevents a certain type of outage, then it's worth the investment. That's much harder in other types of organizations. But that's one way of kind of positioning these types of technologies. The other one, loss of reputation. Anyone, I don't want to say track, but the story about Semantic VeriSign. So Semantic years ago bought VeriSign, VeriSign being a certificate issuer in the public internet space. Semantic VeriSign didn't necessarily have theft of their secrets, but they had a big impact to their reputation. They were found to be issuing certificates they shouldn't. And it's not the first company that's ever been caught this way. But from a reputation standpoint, if you think about things like certificates in the public space, their only business is selling a reputation. If you trust Semantic VeriSign, then you trust every certificate they issue. In their case, they lost their reputation. And that business essentially went bankrupt. Now, it got bought by DigiCert and got turned into the DigiCert portion of certificates, but the net result is the same. Most of us, if you suffer a strong enough if you suffer the loss of information or have an outage that is significant enough to affect your reputation, some organizations can cease to function. Many of them will be able to recover, but there, again, is a cost to the impact to that reputation. So a couple of things that you can do as far as centralizing your secrets. One is try to figure out how you can define some type of private centralized repository. Once you know what those applications are, what types of secrets you have in your environment, whether they're just passwords, encryption keys, APIs, once you know what those things are, there is probably some type of centralized technology that you can use to protect that. Now, I'm going to share a few different options for you, but bringing those together is going to be that limited access scenario, the last pass analogy. If we can at least bring them together, we can control access to it. We can restrict access into those privates in a number of different ways. When we talk about things like CyberArk, if we're going to be protecting passwords, by eliminating the human element of seeing the passwords, we can even control the fact that in order to get on CyberArk, you have to have two-factor or maybe phone factor. We're going to increase the identity protection of who's getting to the secret and then how they're using the secret. The other one, and this is one that comes up quite a bit and a lot of organizations overlook this, separate your data and your secrets, your data and your encryption keys. Do not look to things like AWS and Azure and say, oh, they can host my data and I can put my key up there somehow. One way or the other, that's going to get affected. I am still an advocate today that says, if you want to put data up in AWS, great. Encrypt the heck out of it. Keep the key in your control. Now, things like Azure, they have some options for different technologies to have Key Vault. They also have options where you can bring your own key. Has anyone heard of bring your own key for different scenarios? So bring your own key. This is where you create some type of an encryption key on your premises, either in a piece of hardware or a piece of software. The key is in your possession. The data that is encrypting can be stored wherever you would like. Rather than relying on that manufacturer or that provider to generate and store the key for you, now that key and the data are in the same place. And it only takes one misconfiguration for that key to be divulged. So Microsoft's got a number of solutions around bring your own key. When you look to different technology providers, see if they have some type of bring your own key solution. Protect the key on your own site. The other thing is think about how your data is going to be encrypted. Ideally, we want that encrypted at all times. A lot of providers and software will simply say, yes, you can encrypt the data. But what does that mean? Are they encrypting it just when the system is running? Is it just encrypted at rest? Is it encrypted just on the drive? What about how the data gets moved from one place to the other? Because remember, it's not just the data that they're going to be moving, but if they're using your API tokens or other pieces of secret information, how is that getting moved from one place to the other? The other things that we have here is thinking about administrative and technology solutions. What I mean by this is there's a technology way of approaching these things, and then there's an administrative one. One, I'm not a fan of writing policies that say don't do stupid things with secrets and passwords. People that are going to do stupid things with them are not going to be following your policy. One, I have a firm belief that human beings have an innate way of finding the simplest way of defeating anything that you come up with. The Post-it note password is a great example of this. How do I get around my IT department making me do my password on a regular basis? And this is not a new thing with passwords that are complex in 16 characters. 30 years ago, people were still doing Post-its. Now, it was piece of paper and Scotch tape, but it was still a way of, how do I remember this information? Human beings, and I see this even in organizations where we define a very strong security posture around a PKI. 2 people are going to be present, there's going to be an auditor, there's going to be a camera, and they are on top of their game the day we deploy. Come back a year later, 2 years later, they have found every possible way to stick to the letter of the law, but not quite really be doing what they need to do. Auditors that come in that are supposed to be supervising people on what they're doing are playing Candy Crush on their phone. Are they present? Yeah. Did they sign a log that says that those people were there? Yeah. Did they actually watch what was going on? No. Was it any value? So people will innately just find the easiest way. That's why we have software to prevent people from rolling passwords. You make me change my password every 90 days, what am I going to do? I'm just going to go back and forth between the 2 passwords. So you find some way of preventing that. So humans have a great way of finding out what is the simplest way I can do something. So there is not going to be a comprehensive way where you can say, I can expect my people to always be on the top of their game every time. So for the most part, I don't want to put the burden of this onto people and say, it's your responsibility. You have to keep this information secure. So for me, if I'm going to give you a responsibility or I'm going to give you access to there, I need to verify that. The old trust but verify. I need to actually make sure that this information isn't being sent around. So if I've got all my passwords and all my keys in one place, go take a look at the audit log. Who's looking at this? What are they doing with it? Where's that information going? So you can't just assume that because you've centralized it that the problem's gone away. The other options is think about how are you going to secure that centralized repository. If this is something you're building yourself, how are you going to protect access to that? If you're building a repository where all your passwords are for the organization, but you let people use their passwords to get to the repository, that's not a very strong way of going about it. So I try to think about things of, if I'm going to be protecting information, how do I protect it at least at that same level or higher than what's in there? So a couple of things that you can look at today. So things that you could go out to protect the secrets in your organization. So obviously being the PKI guy, I'm a fan of PKI. So public key infrastructure, we can do things like identity and data encryption. We can move away from passwords. We can encrypt information. We can get people onto identities, either protected with things like YubiKeys or TPM chips. We can make a stronger set of secrets that can't be compromised, or at least not as easily. Start looking at things like password vaults. So move beyond just password managers. Now, I didn't catch the whole last talk, but things like LastPass can do some very basic password audits and tell you that someone's got a 4-character password and hasn't been changed for a while. But move beyond that, moving into some of these vaulting solutions where the passwords aren't exposed. Now, what's nice about this is when you rely on something like a CyberArk or some other vault, because there's no human element, you're not setting the password. You can tell CyberArk, for instance, I want you to roll this key every day. I want it to be 255 characters. Since no one's actually having to interact with it and copy and paste it and change that process, it's all happening behind the scenes. You can have much stronger security. But as in my previous slide, make sure you know how you're protecting access to the cyber vault. If that's going to contain all of the keys to your organization, make sure that that's stronger than anything else that you're doing. The other things that you can look at, key management systems, or KMS, is becoming a stronger and stronger player in the market. There's products from companies like Vormetric that's now part of Thales. Symmetric key management is what these are designed to do. So rather than having all of these passwords and symmetric keys for different applications and different encryptions scattered throughout the organization, they all get vaulted in one place. When an application like SQL needs to decrypt information or some application needs to decrypt something else, they check out their key from the KMS system, they can do whatever they need to do, and gets checked back in again. Now, the downside is you have to have a KMS solution that integrates with whatever your products are, so you kind of go back to the inventory again. What has these symmetric keys? What needs to be protected? How am I going to go about doing that? But now by having all of those keys centralized, I can define minimum standards. Do I want AES encryption symmetric keys? What size? How often are they rotated? Who's getting access? How do I audit and determine where that data is? Our other things like our databases, looking at more than just saying, okay, I BitLockered my database, or at least my database disk, I must be done. There are other types of encryption that are possible, things like TDE and always encrypted, where the data is encrypted even in the processing space of SQL Server. So there are applications now where the database at the table level is encrypted. Whenever the service is running, it's kept encrypted in the memory space. All of the functionality is in encrypted memory, which means even if you were able to blue screen and dump the contents of a server, all that data is protected. So things like the Heartbleed exploit a few years ago with OpenSSL, same type of thing. If the keys or the data is in memory, there's a possible disclosure of that. So always encrypted means we can move away from those models. The other things that you can look at are Azure Key Vault. It doesn't work for every solution, but with Microsoft Key Vault, your keys can be protected in a virtual HSM, if you will, or a hardware product at Microsoft. Not every application they have will integrate with it, but it's certainly better than putting your encryption keys or other types of secrets sitting on a blob or just on a server itself. They can be checked into the Key Vault. Microsoft Rights Management Server, for instance, it uses Key Vault, but it actually has that bring your own key scenario. So with RMS, if you're protecting Office documents and email, you can actually generate your own key on a hardware security module, and then that key is transported to Microsoft into the Key Vault. Not my biggest recommendation, having data and keys in the same place, but if you have no choice. So one of the other things I'll leave you with is the fact that all of these security things are very easy to kind of paint in black and white terms. The approach I often take with customers is we have to be pragmatic about it. We're all associated with some type of an organization or a business. It has to be worthwhile to that organization to do something. We can't just define something as black and white. This is the right way of doing it. It's the wrong way. Security is often associated with some type of a risk, and we're trying to mitigate that risk. And we can deploy a technology, we can put a process in place, we can manage who can get access to that information. But sometimes our risks are simply mitigated by accepting them. And I'm a firm believer in that technology is great and process is great, but sometimes it's just a matter of being able to say, yes, we're aware of the risk, and we accept the risk. It's when you don't know that you've accepted the risk that you run into the biggest problems. So if you didn't realize that having your keys and your data in the cloud, or an application had its secret embedded in the code, you didn't have that full recognition of what that risk was. You didn't have all the information to be able to make that decision. So I'd much rather it be something where the organization says, yes, we're aware of it, either from a financial standpoint or a risk standpoint. We're not going to do anything about it, but we're aware of it. So that's what I have for you today. Any questions I can answer for you? Yes?
So I was curious, can you talk for a minute on some best practices for a PKI solution where you're dealing with certificates on an endpoint, right? Like mobile devices or laptops,
Sure.
kind of like going towards something like ETLS
Yeah.
or device authentication. That's
Yeah.
an area I was curious, it's obviously an entirely complex
Yeah.
topic. But
Sure.
can you give me just some high-level sort of best practices for what you, because I would imagine
Yeah.
that's something you've done.
It does. And so the way I often frame that question is, now how do we what are the best practices around kind of protecting those identities or certificates on something? Oftentimes, it kind of goes back to what I was just talking about, is what risk am I concerned about? And an analogy that I use with organizations is Alice in Wonderland. Is I kind of start talking about risks, and we kind of go down this rabbit hole. And we kind of start talking about, are you concerned about this? Are you concerned about that? So in the case of your wireless scenario, for instance, I would say, are you concerned about a laptop getting stolen and somebody maybe getting on your Wi-Fi network? Okay, you're concerned about that. And we go down the rabbit hole. What about someone deliberately taking a laptop to get on your network? Very different than something goes missing and someone accidentally gets on the network. The other one is corporate espionage. Eventually, you get down that rabbit hole, and it's aliens beaming information out of your brain. And you go, okay, Mark, that's a little far. And you back up the rabbit hole, and you go, okay, here's all the risks that we're concerned about. How do we address those? So in your case, if we are talking about mobile devices getting onto a Wi-Fi network, if I have a deliberate concern about something, I may choose to say, how am I going to protect that? Is it going to be just short-lived certificates that are changed on a regular basis? If I'm concerned about somebody, for instance, it could be, I don't want my employees bringing their iPads to the office and taking the certificate off of a corporate machine and putting on their iPad to get on the Wi-Fi. Okay, I can just make sure that their key can't be exported. So maybe it's sitting inside of a TPM chip. So very different scenarios will kind of drive, what am I going to do to mitigate that risk? Some of them may be, I can't do anything about it. It's not worth, for instance, going out and deploying smart cards for everyone. So there's going to be scales for each type of thing. So I look at it as every certificate has a key, that's secret. How do I need to protect that key and from what?
Right.
So some organizations.
Yeah, you might issue a private key per host, for example.
Yep.
And then you can revoke it. And
Exactly.
Well, some platforms
Yep.
you can set it as non-exportable.
Exactly.
Like Linux, good luck.
Yeah, exactly. And Windows, and that's a great example of defining what my risk is. Because for some organizations, and that's a question that comes up quite a bit, for some of them, it simply is that iPad. I don't want my employee bringing an iPad or their home laptop onto the Wi-Fi network. I just want to make it difficult for them to do that. Well, Windows, I could say that private key is not exportable. Now, I will tell you, I have a piece of software sitting on this machine that ignores that key or that flag and will let you export any key that's protected by Windows. But for that casual employee who's trying to get the laptop on and that option to export the key is grayed out, I've mitigated that risk. A deliberate attacker? No, not so much. Other questions? Yes?
So I have a similar question. So when the endpoint is a phone
Mm-hmm.
and it's an app
Yep.
that uses an API to talk to your server, and you need to have access to an encryption key.
Yeah.
And then you look at the possibility that somebody else may be trying to access your server, well, they can fly.
Yeah. Yeah. Yeah, exactly. So this is one where sometimes it's a technology solution of if I'm set with, I've got something that I need to expose, and I'm going to need to be able to connect to it, and I'm going to obviously want it to authenticate, but how do I keep other people from authenticating? This is kind of going back to different types of secrets. Now, obviously, we have things like passwords, and there's symmetric encryption. Yeah, or symmetric keys. One of the nice things is, why I do a lot in the PKI space is that's a great example of how can you authenticate and secure information without actually sending secret information. So the great thing about PKI or frankly things like CyberVault or other technologies is the fact that I can authenticate. I don't care who's listening because I'm not going to send you anything secret. But yet I can have a very strong identity and very strong access to whatever I'm trying to get to. Now, the challenge is often, you talk about the mobile device. How do I do that on a mobile device? And it's been a changing story. Historically, it's been you're out of luck when a mobile device. The military had issues for a long time. They had something called a CAC sled, which was basically like a really thick phone case, and they could put their smart card into this case to read their identity. A CAC card is really just a PKI smart card. You can start looking at things now. YubiKey, if you've heard of YubiKey, they have now a NFC-capable YubiKey, which means now I can have either a one-time password or a PKI-issued identity and key sitting on a flash drive, and all I have to do is hold it up, and via Bluetooth and NFC, that information can be shared. I don't need to worry about the form factor that I'm connecting to. So there are some newer technologies that enable that mobile scenario. A lot of people are faced with, how do I implement strong identities without killing mobile devices?
Yeah, you can put certs on the slots in the YubiKey now.
Yes, exactly.
So then that becomes then you don't have to put the cert on the device.
Exactly. Exactly. So now with that YubiKey, I can go to a laptop, I can go to a physical machine, I can go to a server, I can hold it near my phone, same identity. The information that's transferred, if I'm doing PKI-based certificates, I'm just sending my certificate and proving possession of the private key. Nothing sensitive is actually sent. In the back.
So in highly virtualized environments, is there a suggested strategy for rotating secrets where you do not have to have outage, where you can like have one being paced in while the others are still being trusted?
Yeah, so I would say that some of those problems exist even in physical environments of how do I rotate things when I've got potentially two or more hosts that are dependent on them, or maybe they're physical versus virtual. Frankly, there's a technology that's been around for a long time inside of Windows, for instance, that a lot of people still don't leverage to this day, things like managed service accounts. So historically, when we wanted an application or a service to run on Windows, we created an application account, we give it the permissions, we give it a password, and we'll go, we'll be really good, we'll change the password on a regular basis, but we never do, because we got to stop it, we got to go where it's at. Managed service accounts kind of turned out on its head, where it's now Active Directory that manages this service account a lot like a computer account. So the computer gets assigned, hey, this is a managed service account, change the password on a regular basis, and it updates the service. Now, if you've got multiple computers and multiple virtual machines, they came out with group managed service accounts. So there are starting to become newer technologies where now I could say this service account and its secret being its password is on 12 different machines, and they need to get rotated in synchronously. Well, group managed service accounts are one way of doing that. Other things, products like CyberArk, enable a centralized place to say, you know what, I'm going to have 12 different identities, and at some interval, I'm going to go out automatically and update those identities. The administrator just interfaces with the CyberArk, for instance. So there's kind of different ways of approaching that, and oftentimes it's driven by what is that application or that operating system. But it does kind of go back to how do I rotate and keep those identities fresh. Other questions? All right, well, thanks for coming. Have a great rest of your day.